The year is 1965. The American highway is an arena of noise, chrome, and ego. Engines scream at full throttle. Twin sticks dance between calloused fingers. And every driver knows one rule. If you want power, you rev it high and shift it fast. But what if everything they believed about power was wrong? What if the loudest engine on the road was actually the weakest idea in the room? And what if the company everyone thought was falling behind was secretly building the machine that would change the rules forever? Because in a factory in Hagerstown, Maryland, inside a company many analysts had already written off, a quiet rebellion was forming. Not a rebellion of speed. A rebellion against speed. While competitors were chasing higher revolutions per minute, a small group of engineers were asking a dangerous question. What if real strength doesn't come from spinning faster, but from pulling harder when everyone else gives up? It sounded like heresy. It sounded like desperation. And in a way, it was both. By the mid-1960s, Mack Trucks was cornered. On Wall Street, it was labeled a bleeding giant. Inside the industry, it was viewed as stubborn, outdated, too loyal to its slow-revving thermodyne engines, while the world embraced the high-pitched scream of modern diesel performance. Rivals like White Motor Company were circling. Corporate pressure was mounting. Market share was slipping. And engines from Detroit Diesel were dominating highways with two-stroke fury that howled past 2,300 revolutions per minute. Drivers loved that sound. It felt like power. But sound is not torque. And torque is what moves mountains. At the center of this storm stood a man who refused to surrender. Zenon C.R. Hansen was not a caretaker executive, he was a believer. On his desk sat a bulldog statue, not decoration, but doctrine. Mack would not become a copy. It would not chase competitors into their own game. Because copying leaders is how you die quietly. Hansen understood something most executives ignore. When you are losing the current game, you do not play it better. You change it. So instead of ordering his engineers to build a louder engine, he authorized something radical. A skunkworks project. A quiet war against conventional diesel thinking. He called it, half jokingly and half seriously, Bulldog Airlines. A private fleet of Learjets and helicopters ferried engineers and blueprints between Allentown headquarters and the Hagerstown plant, bypassing bureaucracy, avoiding leaks, keeping competitors blind. While the industry obsessed over RPM, Mack was engineering something different. Not an engine that spun faster, an engine that pulled harder the slower it turned. To understand why that idea was revolutionary, you have to understand the problem every truck driver faced in 1965. Diesel engines at the time were narrow-band machines. Horsepower and RPM were married. As engine speed climbed, power climbed. As engine speed dropped, power fell away. On a steep grade, when RPM dipped, the engine lost its mechanical edge. The truck slowed. The driver downshifted. The revs screamed again. That was the dance. And that dance required the twin-stick transmission. 2 gear levers, one for the main gearbox, one for auxiliary ranges. Drivers split gears constantly, keeping the needle in the narrow, sweet spot. It was an art form, a rhythm, a badge of honor, but it was also a workaround. Because the engine could not pull broadly, the transmission had to compensate. Chief Engineer Walter May and plant leader Winton Pellizzoni looked at this entire system and asked a forbidden question. What if the transmission was not the hero? What if it was the crutch? Their concept was called constant horsepower. In simple terms, they wanted an engine whose horsepower curve did not peak like a mountain, but stretched flat like a plateau. An engine that would increase torque as RPM dropped, keeping usable power steady across a wide range. In 1965, that sounded like physics fiction, because a diesel is fundamentally an air pump. To create torque, you burn fuel. To burn fuel efficiently, you need air. At low RPM, exhaust flow is weak. A turbocharger spins slowly. Air density drops. The engine suffocates. Torque collapses. Every engineer in the industry knew this. May and Pellizzoni decided to cheat it. They redesigned the fuel system to deliver controlled fuel at lower speeds. They engineered what became known as the tip turbine system, an air-driven intercooler fan designed to densify intake air even when road speed and exhaust flow were low. They forced the engine to breathe when physics said it shouldn't. It was mechanical audacity. Hansen bet the company on it. In 1967, to protect Mack from takeover attempts and buy time for development, he orchestrated a merger with Signal Oil. It was not about synergy. It was about survival. Cash flow became oxygen. The engineers kept working. There was no plan B. When the prototype ENDT 675, later branded MAXIDYNE, was strapped to the dynamometer, the room expected incremental improvement. What they saw instead was a flat line. 237 horsepower, constant, from roughly 1,200 to 2,100 revolutions per minute. But the real shock was torque. Industry standard torque rise hovered around 15%. The MAXIDYNE exceeded 50%. It delivered 906 pound-feet at just 1,200 RPM, exactly where conventional engines would have coughed, smoked, and died. Instead of collapsing as speed dropped, it surged. It behaved less like a racing engine and more like a steam locomotive. The lower it dug, the harder it pulled. And that is when the second problem emerged. The MAXIDYNE was too strong. Transmissions designed for high RPM, lower torque, engines were not built for this kind of low-end twisting force. Drive shafts snapped. Axle components protested. The engine was not the weak link anymore. The drivetrain was. Think about what that means. For decades, engineers had designed transmissions to multiply torque because engines could not provide enough across a wide band. Suddenly, here was an engine that made many of those gear splits unnecessary. If an engine can maintain power across 900 RPM of operating range, you do not need 12 closely spaced gear ratios to keep it alive. You need fewer gears, which means fewer shifts, which means less fatigue, which means the twin stick, the king of the highway, becomes optional. And optional technologies do not survive long. But the industry did not believe it yet, because on paper, 237 horsepower did not sound impressive. Competitors advertised similar numbers with more noise, more RPM, more drama. The difference was invisible to anyone who did not understand torque curves. So Mack did something bold. They put the MAXIDYNE on the road. One of the proving grounds was the Grapevine, the notorious grade on Interstate 5 in California. Trucks that misjudged gearing there could crawl in humiliation. Conventional engines attacked hills at high RPM. When revs dropped, drivers downshifted aggressively to stay in the narrow power band. It was noisy. It was frantic. The MAXIDYNE approached differently. Drivers could hold a gear longer. As RPM fell, torque rose. Instead of scrambling for a downshift, the engine dug in. The truck climbed steadily, without the mechanical panic drivers were used to. At first, many did not trust it. Years of habit told them to shift, but the engine did not ask for it, and that is where the cultural war began. Because technology can change physics overnight. It takes longer to change pride. Twin-stick drivers were elite operators. Managing two levers required coordination, anticipation, mechanical sympathy. It was a craft, a rite of passage. The MAXIDYNE threatened to make that craft less necessary, not obsolete overnight, but less central. And in industries built on identity, that matters. Yet fleet owners saw something else. Fewer shifts meant less clutch wear. Broader torque meant simpler transmissions. Simpler transmissions meant lower maintenance costs. Lower maintenance meant higher uptime, and uptime is profit. The MAXIDYNE did not just change how trucks felt. It changed the economics of trucking. Instead of building ever more complex gearboxes to compensate for narrow engines, Mack offered a system built around torque dominance, fewer ratios, stronger components, smarter calibration. The twin stick had been a solution to a limitation. Remove the limitation, and the solution becomes inefficiency. That is how revolutions really happen, not with explosions, with simplifications. As adoption grew, competitors took notice. Wide torque bands became desirable. Engineers across the industry began rethinking calibration strategies. Instead of chasing higher redlines, they chased usable mid-range strength. The philosophy shifted. Performance was no longer measured only by how fast an engine could spin, but by how confidently it could pull without drama. And in that shift, the twin stick's empire began to shrink. It did not disappear overnight. Specialized heavy-haul operations still valued ultra-fine control. Enthusiasts still loved the rhythm of split gears, but mainstream fleets increasingly chose efficiency over ritual. The MAXIDYNE had proven something radical. Noise is not power. Complexity is not strength. Sometimes the strongest machine is the one that works hardest when everyone expects it to fail. And in proving that, Mack did more than launch an engine. It changed the logic of drivetrain design. But the deeper lesson is not mechanical. It is strategic. When you are losing the current race, you can either run faster or you can redefine the finish line. And Mack chose the second option. While competitors invested in higher RPM and marketing spectacle, Mack invested in torque curves and system integration. They understood that most customers did not care about how loud an engine sounded at peak output. They cared about whether a fully loaded truck could climb without constant gear hunting. They focused on the moment of strain, because that is where loyalty is built. Over time, the implications expanded. Engines with broad torque curves paired naturally with simplified gearboxes. Simplified gearboxes paved the way for automated manual transmissions. Automation required predictable torque delivery. Decades later, when electronic shifting systems became common, the foundational requirement was the same principle May and Pellizzoni chased in 1965. Wide, stable torque. The MAXIDYNE was not just an engine, it was a pivot point. It signaled the beginning of the end for an era defined by mechanical multiplication and the rise of an era defined by intelligent power delivery. And it saved Mack in the process. Because innovation born from desperation often carries clarity. Hansen refused to copy. He refused to chase noise. He bet everything on a quieter idea. And that bet worked. The company survived the takeover threats. It stabilized. It rebuilt its reputation not as the loudest brand, but as the bulldog that pulled hardest when the hill steepened. Which is a metaphor far beyond trucking. In markets, in careers, in industries, the loudest player is not always the strongest. The fastest moving trend is not always the most durable. Sometimes the winning move is not acceleration, but leverage. The twin stick was a masterpiece of coordination. The Maxidine made that coordination less necessary. And in doing so, it demonstrated a principle that applies far beyond diesel engineering. When you eliminate the constraint, you eliminate the need for complexity. That is how the engine that killed the twin stick truly did it. Not by attacking it directly, but by making it optional. And in competitive environments, optional is the first step toward obsolete. The highways eventually grew quieter. Not silent, but different. Fewer frantic shifts, broader pulls, engines digging instead of screaming, drivers adapted, fleets calculated, engineers recalibrated, and the idea that horsepower must peak sharply at high RPM faded into history. All because a small team in Hagerstown decided that maybe, just maybe, power should not collapse when speed drops. They were told it could not be done. They did it anyway. And that is how a company under siege rewrote the physics of its own survival. What made the Maxidine truly disruptive was not just its torque curve, but the chain reaction it triggered across the entire heavy-duty ecosystem. Because once fleets experienced an engine that could hold a gear longer, climb without panic, and recover without screaming toward redline, expectations shifted permanently. And when expectations shift, markets follow, and when markets follow, engineering priorities are forced to evolve. And that is exactly what happened in the late 1960s and early 1970s as competitors quietly began studying wide torque rise instead of simply advertising peak horsepower numbers. The traditional equation had always been simple: more RPM equals more power, more gears equal more control, more shifting equals more efficiency, but the Maxidine shattered that logic by demonstrating that if torque rises as RPM falls, then power does not collapse under load, and if power does not collapse, then the driver does not need to constantly chase the sweet spot. And if the driver does not need to constantly chase the sweet spot, then the transmission no longer needs 12 tightly spaced ratios to compensate for a narrow band engine. This was not incremental improvement. It was philosophical inversion, because the gearbox had spent decades compensating for engine weakness, and suddenly the engine became strong enough to compensate for gearbox simplicity. And when that reversal happens, the entire hierarchy of design priorities changes from the crankshaft outward. Fleet data began to confirm what early adopters felt intuitively. Fewer shifts reduced clutch wear, reduced synchronization stress, reduced driver fatigue, and improved route consistency. And consistency is the invisible metric that separates survival from dominance in freight economics, because a truck that performs predictably across terrain reduces downtime variability and maintenance forecasting uncertainty, and that predictability compounds into financial stability over thousands of operating hours. Drivers who initially resisted the Maxidine because it threatened the ritual of the twin stick slowly began to recognize the advantage of pulling through grades without frantic downshifts, and pride gave way to pragmatism as hill climbs became smoother and long hauls became less physically punishing. The twin stick had symbolized mastery, but mastery over complexity is less valuable than mastery over efficiency. And as younger drivers entered the workforce without decades of split-shifting habit, the transition accelerated. Competitors could not ignore the numbers, and although marketing departments continued to emphasize horsepower wars, engineering departments quietly began investing in broader torque calibration, improved turbo response, and fuel delivery strategies that emphasized mid-range strength. Because once one manufacturer proves that usable torque across a wide band increases real-world productivity, the market begins to demand it everywhere. Over time, the philosophy expanded beyond mechanical systems into electronic control, because a broad, stable torque curve is the foundation required for automated shifting algorithms, and without engines that can tolerate RPM, variation without collapsing automation becomes unreliable, which means the Maxidine's torque-first logic indirectly paved the way for automated manual transmissions decades later. The irony is profound. The same principle that weakened the twin stick's dominance eventually made manual shifting itself less central in mainstream trucking. Not because drivers lacked skill, but because engineering removed the necessity for constant intervention. The economic implications deepened as fleets standardized around simplified drivetrains, because inventory management improved when fewer transmission variants were required. Technician training streamlined when systems were less mechanically intricate, and downtime decreased when fewer moving parts demanded synchronization precision, and each of those marginal gains compounded across national freight networks. Mack did not simply sell an engine. It sold a new operating philosophy centered on leverage rather than velocity, and leverage scales. Better than velocity because it multiplies output without proportionally increasing input. When torque remains strong at lower RPM, fuel consumption stabilizes under load, and while efficiency gains varied by duty cycle, the psychological impact was consistent. Operators felt in control rather than reactive. By the mid-1970s, the conversation had shifted from whether wide torque rise was viable to how much torque rise was optimal. And once that question becomes industry standard, the original disruptor has already won the ideological battle. The MAXIDYNE did not eliminate the twin stick by decree. It rendered its necessity conditional, and conditional tools fade as alternatives prove more economical. And although specialized heavy-haul segments retained compound transmissions for extreme applications, the mainstream center of gravity had moved. Engineering students entering the field studied torque curves differently. Powertrain integration strategies evolved, and calibration became as important as raw displacement. The deeper strategic lesson echoes far beyond trucking. When an industry converges on a shared assumption, innovation often emerges from challenging the variable everyone takes for granted. And in 1965, that variable was RPM as the primary path to power. By shifting focus to torque rise at low speed, Mack redefined performance in terms customers actually experienced, rather than numbers they merely heard. And that distinction between perceived power and usable power is what allowed a company under financial siege to alter the competitive landscape. The MAXIDYNE proved that revolutions do not always arrive with higher numbers. Sometimes they arrive with flatter curves, quieter confidence, and systems that simply refuse to stall when pressure increases. As the years passed, the narrative surrounding power in heavy trucking quietly transformed, because once operators experienced an engine that could lug confidently without self-destruction, the psychological threshold of acceptable RPM changed, and when psychology changes, mechanical standards follow. And when standards follow, the supply chain reorganizes itself around new assumptions. Transmission manufacturers began reinforcing components not to survive frantic high-rev shock loads, but to handle sustained low-end torque. Axle ratios were reconsidered to complement broader pulling bands, and fleet purchasing managers started asking a different question during procurement meetings. Not how high does it rave, but how does it pull at 1200? And that subtle shift in language signaled a structural change in the market. The twin stick did not disappear in a dramatic collapse. Instead, it entered a slow fade, remaining respected but no longer required in the majority of long-haul applications. And when a tool transitions from necessity to specialty, it loses its dominance even if it retains admiration. Veteran drivers could still split gears with surgical precision, but new hires trained on torque-rich engines discovered that fewer shifts meant less cognitive overload in dense traffic, fewer missed gears under stress, and more attention available for route awareness, weather conditions, and safety compliance. The cab environment evolved from a constant mechanical negotiation to a more stable operational space, and stability compounds into safety over millions of highway miles. Competitors responded not by copying the MAXIDYNE outright, but by internalizing its principle, broadening torque curves across product lines and marketing durability rather than just acceleration. And over time, the horsepower wars lost some of their theatrical dominance as fleets demanded balance between output and longevity. Engineering departments began modeling drivetrains as integrated systems rather than isolated components, recognizing that an engine's torque behavior determines gearbox complexity, which determines maintenance cycles, which determines life cycle cost projections. And once life cycle economics become transparent, the market rewards simplification that preserves capability. The ripple effects reached training programs and technical schools, where curriculum gradually incorporated torque management strategies over high RPM performance emphasis, and that educational pivot reinforced the cultural normalization of wide-band pulling power. As emissions regulations tightened in later decades, the advantage of operating efficiently at lower RPM became even more relevant, because engines calibrated for strong mid-range torque could meet evolving standards with less reliance on extreme rotational speed. And once electronic controls entered the equation, the groundwork laid by torque-first philosophy made digital optimization feasible. Looking back, the MAXIDYNE represents a case study in counterintuitive innovation because it emerged at a time when louder and faster seemed synonymous with progress. Yet it succeeded by challenging that equivalence and redefining progress as controlled strength under strain. It validated the idea that systems perform best when their core weakness is addressed rather than masked by additional complexity, and in addressing the narrow power band limitation, directly Mack reduced the need for mechanical multiplication downstream. That is the essence of structural disruption. Remove the root constraint, and peripheral mechanisms reorganize automatically. By the time automated manual transmissions began gaining mainstream acceptance decades later, the intellectual lineage traced clearly back to wide, stable torque curves. Because automation thrives on predictability, and predictability requires engines that do not collapse when RPM fluctuates. The MAXIDYNE did not foresee digital shift algorithms, yet its philosophy enabled them by normalizing broad usable power. The twin stick became a symbol of an earlier era defined by compensatory engineering, admired for its skill, demand but gradually outpaced by integrated design logic. In strategic terms, Mack demonstrated that survival under pressure often demands reframing the metric of competition rather than intensifying effort within existing metrics. And by redefining what constituted real-world performance, the company preserved independence at a moment when acquisition seemed inevitable. The Bulldog on Hansen's desk was more than branding. It was a declaration that resilience sometimes means resisting trends long enough to build a better alternative. When the MAXIDYNE proved itself on grades, in quarries, and across freight corridors, it validated that philosophy in steel and torque rather than slogans. The engine that killed the twin stick did so not through confrontation, but through irrelevance. Because once a machine can maintain strength across a wide operational range, the elaborate dance of constant gear splitting loses its economic justification. Industries rarely abandon tradition willingly, but they abandon inefficiency eventually. And the MAXIDYNE accelerated that inevitability by demonstrating that simplicity anchored in strength outperforms complexity anchored in limitation. That is why its legacy endures, not merely as a product milestone, but as a strategic lesson in how to win by rewriting the assumptions everyone else accepts. And as the industry moved into the late 20th century, the full magnitude of that shift became impossible to ignore, because fleets that once evaluated trucks primarily on advertised horsepower began scrutinizing torque curves, maintenance intervals, and total life cycle cost projections with far greater intensity. And once procurement decisions are driven by life cycle mathematics, rather than showroom theatrics, engineering priorities harden around durability and usable performance instead of spectacle. The Maxidyne's wide torque rise proved especially valuable in vocational sectors like construction, logging, and refuse hauling, where stop-and-go cycles and heavy loads punish narrow-band engines. And in those environments, the ability to pull cleanly from lower revolutions without constant shifting translated directly into uptime stability and operator confidence. What started as a survival gamble inside a threatened company evolved into a template for powertrain integration. Because once engineers witnessed the cascading benefits of broad torque delivery, they began designing entire drivetrains as cohesive systems rather than loosely matched components, aligning gear ratios, cooling strategies, and fuel calibration around sustained pulling force rather than peak rotational speed. This systemic thinking influenced supplier relationships, parts standardization strategies, and long-term research investments across the heavy-duty landscape, reinforcing the principle that eliminating a bottleneck at the source simplifies every layer downstream. Meanwhile, cultural memory preserved the twin stick as a symbol of an earlier, more tactile era of trucking, where driver skill visibly manifested in every split shift, yet nostalgia could not override the arithmetic of efficiency. And as regulatory frameworks tightened around safety, emissions, and driver hours of service limits, the reduction of unnecessary mechanical workload became not just an advantage, but a compliance asset. A truck that could maintain grade without frantic downshifts, reduced distraction improved operational margins in ways that extended beyond fuel or clutch wear, touching insurance rates, scheduling predictability, and risk management analytics. The Maxidyne also altered competitive psychology because it proved that innovation does not require chasing the loudest narrative in the market. Instead, it requires identifying the hidden constraint constricting performance and attacking it directly, and in 1965, that constraint was the narrow torque band accepted as inevitable. By widening it, Mack converted weakness into leverage and turned a defensive posture into strategic offense, demonstrating that differentiation rooted in engineering fundamentals outlasts differentiation rooted in marketing emphasis. As electronic control modules matured and data logging became standard, the advantages of stable torque curves became quantifiable in real time, validating decades-old intuition with measurable telemetry. And fleets could now observe fuel consumption patterns, RPM stability, and shift frequency statistics that reinforced what early Maxidyne adopters sensed instinctively on steep grades. The narrative of power fully transitioned from how high an engine could scream to how intelligently it could sustain load without drama, and once that narrative stabilized, the twin sticks era concluded not with ceremony, but with quiet obsolescence. In hindsight, the Maxidyne was less an isolated breakthrough and more a pivot in industrial mindset, illustrating that when a company reframes a performance variable, it can reshape an entire value chain. And Mack's decision to prioritize torque rise over RPM escalation stands as a case study in strategic inversion, where solving the root constraint dissolves peripheral complexity. The highways grew more efficient, not because engines became louder, but because they became smarter in how they delivered force, and that transformation rippled outward into automated systems, integrated diagnostics, and global supply networks built around torque-first philosophy. The Bulldog survived not by outrunning competitors in their chosen race, but by redefining the terrain of competition itself, and the engine that ended the reign of the twin stick did so by making frantic shifting unnecessary in the majority of real-world scenarios, proving that when strength is distributed broadly across the operating range, complexity loses its throne. In the end, the lesson endures far beyond diesel engineering. The most durable revolutions often emerge not from acceleration, but from leverage, not from noise, but from controlled force, applied exactly where others falter. And once leverage becomes the defining advantage, momentum follows quietly but decisively, because markets reward solutions that reduce friction at scale. And the MAXIDYNE reduced friction everywhere it touched, from the driver's left leg no longer dancing endlessly on the clutch to the maintenance department, tracking fewer premature component failures, and that reduction in friction compounded into measurable resilience during volatile economic cycles when freight demand fluctuated and margins tightened. Companies operating torque-rich fleets discovered that stability under load translated into stability under financial pressure, and that connection between mechanical behavior and economic durability revealed something profound. Engineering decisions ripple far beyond metal. As international competition intensified and globalization reshaped supply chains, the emphasis on integrated system performance became even more critical, because trucks were no longer isolated tools operating in predictable domestic corridors, but nodes in complex logistical networks where downtime in one region cascaded across continents. Engines that could tolerate RPM variation without constant driver correction fit naturally into this interconnected environment, reinforcing reliability as a strategic asset rather than a marketing slogan. The MAXIDYNE's philosophy aligned with that emerging reality long before digital dashboards quantified it. Meanwhile, the mythology of high-rev dominance gradually softened as operators recognized that sound and speed did not guarantee efficiency. And younger generations entering the industry viewed wide torque bands as standard rather than revolutionary, which is often how paradigm shifts complete themselves. What once defied conventional wisdom becomes assumed baseline. By the time fully automated transmissions became viable in heavy-duty applications, the intellectual groundwork had already been laid decades earlier, because automation depends on engines that behave predictably across broad operating ranges. And predictability was precisely what the MAXIDYNE normalized. The twin stick never vanished entirely. In specialized heavy-haul niches, it remained respected for its granular control. Yet its cultural centrality faded as the mainstream embraced simplified drivetrains optimized around torque accessibility. That transition illustrates a broader truth about technological ecosystems. When the core variable changes, supporting structures adapt or recede, and torque rise was the variable that shifted the equilibrium. Once engines could sustain power without frantic gear multiplication, the elaborate choreography of dual levers became an optional flourish rather than a necessity. Strategically, Max Gamble under Zenon Hansen's leadership demonstrates how existential pressure can catalyze clarity, because the company's vulnerability forced it to question assumptions competitors accepted as fixed, and that willingness to challenge the RPM dogma unlocked a path competitors initially overlooked. In boardrooms and design studios across the industry, the lesson resonated. Differentiation rooted in structural improvement outperforms imitation rooted in trend chasing, and companies that address foundational constraints reshape markets more effectively than those that chase incremental noise. Over time, the MAXIDYNE's legacy embedded itself in engineering curricula, fleet management philosophy, and drivetrain architecture, becoming less a product name and more a principle. Prioritize usable power across real operating conditions. That principle influenced how torque curves were modeled, how turbochargers were tuned, and how calibration strategies balanced fuel delivery with durability. It encouraged engineers to think in terms of systems, not isolated peaks, and that systemic mindset accelerated the industry's evolution toward smarter, more integrated machinery. In the final analysis, the engine that ended the dominance of the twin stick did so not by erasing skill, but by reducing unnecessary strain, not by silencing tradition, but by outlasting it economically, and not by overwhelming the market with spectacle, but by quietly proving that strength under pressure is the ultimate competitive advantage. The highways changed not because drivers forgot how to shift, but because they no longer had to shift as often, and that subtle difference marked the transition from compensatory engineering to integrated design. The MAXIDYNE stands as a testament to the power of questioning the obvious, of redefining performance at its source, and of understanding that sometimes the most transformative revolutions are those that make complexity irrelevant. And when complexity becomes irrelevant, entire cultures reorganize themselves around the new normal, because once operators experience reduced strain, they recalibrate their expectations permanently, and fleets that transitioned to torque-dominant architectures began demanding the same smooth pulling characteristics from every subsequent platform they evaluated. Procurement conversations shifted from "how fast does it climb" to "how steadily does it hold?" And that linguistic evolution signaled a deeper cognitive shift across the industry. Engineering departments responded accordingly, refining fuel injection timing, turbo boost strategies, and cooling efficiency to sustain low RPM torque without sacrificing durability. And as metallurgy improved and computational modeling advanced, the original MAXIDYNE philosophy gained even greater refinement. What began as a bold deviation matured into a sophisticated standard, influencing not only vocational trucks, but line-haul tractors and export platforms competing in diverse terrains from mountainous regions to congested urban corridors. The broader economic impact surfaced in training pipelines as well, because reducing reliance on constant split shifting shortened the learning curve for new drivers entering the profession, easing workforce bottlenecks during periods of expansion. By lowering the mechanical intimidation factor without compromising capability, torque-rich drivetrains subtly widened access to the industry, and in doing so, they stabilized labor supply in ways rarely credited to engine design. The link between torque curves and talent pipelines might appear indirect, yet in practice, it proved tangible. Insurance actuarial models quietly benefited too, as smoother grade transitions and fewer abrupt gear corrections reduced certain categories of mechanical incidents, reinforcing the idea that stability compounds advantage across multiple layers of an ecosystem. Reliability is rarely dramatic, but it is relentlessly cumulative. And the MAXIDYNE's broad torque delivery fostered exactly that kind of cumulative strength. Even competitors who initially dismissed the approach gradually integrated similar torque rise strategies into their own platforms, illustrating how innovation diffuses once validated in real-world conditions. Market resistance gave way to adaptation, and adaptation confirmed the original thesis. Sustainable pulling force across a wide RPM band simplifies operations more effectively than chasing peak numbers at narrow extremes. The industry did not merely copy a product, it absorbed a philosophy. By the dawn of the 21st century, electronic controls, emission standards, and automated transmissions converged around principles that echoed the MAXIDYNE's foundational insight, proving that the engine's legacy extended far beyond its original displacement or horsepower rating. It reshaped the conversation about what power truly meant in heavy-duty transport, reframing it as endurance rather than aggression, as composure rather than spectacle. And so the twin stick, once emblematic of mastery, became a historical artifact of a time when machinery demanded constant negotiation between driver and drivetrain. Its decline was not a loss of skill, but an elevation of design, a movement from compensating for limitations to eliminating them at their root. The MAXIDYNE did not simply replace a shifting technique, it altered the balance of responsibility between human and machine. In the end, the story is not merely about an engine configuration or a transmission format, but about strategic courage under pressure, about a company confronting vulnerability and choosing reinvention over retreat. The MAXIDYNE stands as enduring proof that redefining the core variable of a system can dissolve entrenched norms, and that when leverage is applied precisely at the constraint, even the most iconic mechanisms can quietly fade into history.